Hello, pre-calculus. I hope you guys are doing good today, and we are going to go over some properties of logs and how we can condense and expand them so that we will have these techniques down for when we solve them. So let's go ahead and get started. So let's list our properties first. So here we go. So properties of logs. So here is your first one. Your first one is the product property. So if I have log of base A, and then I have a UV right here, I can expand this by using addition. Okay, and that would be the same thing if I had a natural log of UV. I could expand that and say natural log of U plus natural log of V. So that is your first property. The second one is going to be quotient. Okay, quotient means it's going to look something like log base A of U divided by V. And we can expand this by using subtraction. And then we can have natural log of U divided by V. And again, we can expand that by using subtraction. Okay. Then let's get another page because I wrote so big. Oh, up there. Okay, so then let's do our last one, which is our power property. Okay, power property says if I have log of base A U to the nth power, I can take this power and I am going to power down. Now that's what I like to call it. So that means we can write in log A of U. Okay, and the same thing works for natural log of U to the n. Okay, we power down so the n goes in the front of natural log of U. Okay, so let's try some examples. Okay, so the first example that I would like to do is going to be, we'll let this be number one, log of 3x squared y. So we are going to be expanding these. Okay, so my first question to you would be, how is the 3, the x squared, and the y all attached? Okay, so they are all attached by multiplication. So I'm gonna use a different color so I can show kind of rewriting it, so maybe it would help with understanding what I'm getting ready to do. If you remember from our properties, if they're being multiplied, to expand them, we are going to add. Okay, so that's what we're looking at. So here I want to expand these by addition. So I'm going to have, change back to pen, log 3 plus log x squared plus log y. So we have took 1 log and now we have expanded it into 3 logs, but we're not done yet. So if you look at here, we have a power. We are not completely expanded until we power down. So your last step would be to power the 2 down. So log 3 plus 2 log x plus log y. And then we have expanded the log. Let's look at another one. So example number 2. We have natural log square root 4x plus 1 all over 8. My first question to you is going to be, what do we have going on here? So we're looking at product rule, quotient rule, power rule. What do you see? I'm hoping the one that you see first would be the quotient rule. So we know that we're going to be subtracting these to expand them. But a harder one to see is this top. Okay, that top is understood to be a power. Square root means what? Power. And hopefully you said a half over 8. So now we're going to expand using the quotient rule. So I'm going to write natural log 4x plus 1 to the half minus natural log of 8. Then the very last step is to power down. So we're going to have 1/2 natural log 4x plus 1 minus natural log of 8. And we have completely expanded. Now, let's try examples for condensing. Okay, so here would be example, we'll just go with example 3. Okay, so this example is for condensing. So you will be given a big problem, like an expanded problem, and then we are going to have to condense it down to 1 log. So normally on the expanding, our power rule is always last. Condensing, our power rule is always first. So the first thing I want you to do is take your power and power up. Take your power and power up. So we will have log of x to the 1/3 plus log of x minus 3 to the 5th power. Normally I would have you multiply that out, but to the 5th power it would be crazy, so we're going to leave it as is. So the last step is to put them together by multiplication. But before I jump straight to that, I want us to look at one thing here. Let me actually highlight that a different color. Okay, we'll use blue. I need us to fix it. So just like up here, we had to change it to this, I need you to fix it and change it back to what it should look like. So the power of a 1/3 should be cubed root. So we're going to need to change that to cube root. And since I'm running out of room on the bottom, I'm just going to do that when we take care of our addition. Addition means we multiply. So we're going to have log of the cubed root of x, and we are going to multiply that times our x minus 3 to the 5th power. And that would be our answer. Now, if that's a little confusing and complicated for you, like it's kind of run on, you could put brackets right here if you would like, so that you can see that it's log of all of that. So all of this together will be your answer. Okay, remember, condensing means we're bringing it down to 1 log. Okay, let's look at another one. Call this example 4. So we have 4 natural log of x minus 4 minus 2 natural log of x. First step, power up. So we have natural log x minus 4 to the 4th minus natural log of x squared. So like I said on the other one, I would probably have you multiply that out, but x to the 4th is still a little crazy, so we're not going to touch that. So we're going to leave it like this. Last step, subtraction means what? Yep, divide. So write these as a fraction. And then you just condensed it to 1 log. Last example, we have 1/5 log base 3 x plus log base 3 x minus 2. Okay, notice our first step is to make sure we don't need to power up, but we do. But notice what happens here. We actually have to power to both of these so it's on the outside. So yes, I normally tell you to power up. So this is up to you. You can power up and distribute the power to every single term on the inside. So that would be distributing to this one and to this one. Or you could condense it and then power up. So either way would actually still give you the same answer, so you're good. So in this case, since it's a little bit complicated, I'm going to go ahead and do the inside first by multiplying. So I'm going to have 1/5 log base 3 x minus 2. Now remember, I'm going to use brackets. Remember, this is all together. So that when you take your power and you power up, please note that that goes on the outside. So it would be log 3 x minus 2 gets the power of 1/5. But remember, on this other example, we don't leave it as the 1/5. We have to convert it back to the radical form. So I'll come over here this direction and write log base 3 5th root of x minus 2. And then here is your condensed answer. Hope this helps you guys.